Hello, everybody. Welcome to the fourth episode of the Pixel Perfect Podcast. I am your host, Pixel Perfect Runs, not Pixel Perfect Podcast. But welcome to the show. We have a very special guest, SethBling. And if you do !PixPod, it'll give you a bit more information about Seth and where you can watch some of the last podcast episodes. So without further ado, here's SethBling. So yeah, welcome to the stream. Could you tell us a little bit about yourself, maybe, and maybe where people have heard your name from?
Yeah, a lot of people have heard my name from things other than speedrunning or machine learning. Minecraft. I have a YouTube channel where I've done a lot of Minecraft content. YouTube.com/SethBling. Check it out.
Mm-hmm.
Yeah, I did that for many years. I had like 2 million subscribers over there. But I have also done a lot of various speedrunning exploits throughout the years, using the word exploit very literally, and some machine learning projects, and we're going to talk about all of that today.
Yeah, so you actually just finished up a stream where you did some Super Mario Land speedruns. So how
That's
did
right.
that go?
Went well. I did. I got 3 PBs, got a lot of gold splits. I cut off almost a minute from my PB because it was not a very good PB in the first place, but I'm working on it. It's my second day of runs, so things are improving pretty fast.
Nice. So I guess we could get into what we're really going to talk about for the main part of the podcast. So when I do speedruns and you did it for Super Mario Land, you like to go through, maybe execute a glitch here and there, but mostly, you play throughout levels. But sometimes you do something a bit different, specifically in Super Mario World. So can you tell us a little bit about maybe what that is and how it's done?
I think you're talking about credits warps.
Yes.
Am I on the right track? Yeah.
Yep.
So I've been heavily involved in the Super Mario World, the development of the Super Mario World credits warp. About 5 years ago, Jeff W356 discovered a human viable route for an arbitrary code execution glitch that would cause the game to play the credits. So this sort of thing has been done by TaskBot. TaskBot is like a circuit board that can plug into a Super Nintendo and execute a tool-assisted speedrun in order to do all kinds of crazy glitches and shenanigans. And so it's at that point it was not like a new thing to have like a task doing arbitrary code execution, but to have a human doing that and actually glitching out the game so hard that you can tell it to run your own like code was a new thing, like by hand. So Jeff W356 came up with the first route for that. He actually did a speed run of Super Mario World using the route that he came up with, and pretty much no one believed it was legitimate. What happened was he just sort of like did the run, the VOD started circulating a little bit, and everyone's just like, what is this? Like, you're doing some weird things, bouncing on some Koopas in weird places, and these things don't really make sense. And so for a while, like, the task community thought that like it didn't make any sense. The RTA community thought it made even less sense because we didn't know anything about what was going on there. And eventually it actually turned out that the task community figured out how it worked. Jeff kind of told them about how his setup worked, and someone was able to actually do a task that like verified that the techniques would work. But that information took a while to make its way over to the RTA, the real-time community. And at AGDQ 2015, I talked to Dram about it. Dram was a legendary Super Mario World speedrunner. Mm-hmm. And he talked about how the task community had actually verified it. And I started looking at it at AGDQ 2015, and I started to think that it was, something that a person could do, which was not really a mainstream opinion at the time. And so I went about learning how to do it. I actually talked to Jeff W, and he helped me along with it too. And I started doing some practice, and after a week or two, I was able to actually complete the first run on console. Jeff W's run was on emulator, and you never really know if that's like if it's emulating the game correctly or if was using RAM watch or whatever. So verifying it on console was a big step. I mean, it basically made the whole thing legitimate. And yeah, his original time was about 5 minutes. My first run was actually 6 minutes. It was slower than his. The next day, I was able to beat his time by like a minute or something.
Oh wow.
And from there, we improved the route a lot. We came up with a lot of optimizations. It wasn't just me; it was a lot of other people working on it. Um, and that's sort of how the whole thing broke into the mainstream and became a little bit of a viral sensation.
Yeah, so how does it actually work? Like, like you said, you kind of throw some Koopa shells some places, you stomp on some Koopas, you hit a block here, you put Yoshi in a specific pixel. What are you actually doing to manipulate the game to kind of break in such a way so that you can warp all the way to the credits?
Mm-hmm. Yeah, so it's a little bit complicated, but I'll try and break it down the best I can in a way that's not too hard to understand. There's this glitch called the item swap. It's used in 11 exit speedruns of Super Mario World to get a cloud in your inventory, in your item box. The item swap relies on some basically a bug that the coders didn't notice when they were programming the game, where you can trick the game into eating something, letting you eat with Yoshi something that Yoshi would not normally be able to eat. So normally Yoshi can stick out his tongue, grab a coin, eat it. When you eat it, you'll get a coin. Whatever. If he sticks out his tongue and eats a mushroom, you'll eat it. You'll get the power up. Mario will become big. You can eat some enemies, and so when you do that, whenever Yoshi eats something using his tongue, the game looks into a table to figure out like what power up or should I give you into your item box, and like what code should I run? Should I run some custom code, and like from somewhere in the game cartridge? So like when you get a star, it runs some code that makes you invincible for a little while, right?
Yeah.
So when you get the cloud in 11 exit, that's because when you execute that item swap glitch and eat a charge and chuck, the charge and chuck is not one of those, is not basically something that's ever supposed to be eaten by Yoshi, but because the item swap, you can do it. And so when you like look up into the table for what power up to give you and what code to give you, or what code to run, it's sort of like you're looking outside of the actual table that they coded into the game, and it's kind of using garbage values from elsewhere in the ROM in order to figure out what to do. And so it gives you the cloud when you eat a charge and chuck. It also runs some code that normally crashes the game. There's some ways to prevent the game from crashing if you do certain memory setups. And that's how you get the cloud for 11 exit. For the credits warp, we can use it to trick the game into running our own code. And so that's very, very technical, and I can't possibly go into how that works. But basically, the gist of it is it uses the game ends up looking in certain places in RAM to see what it should do, and running code from places in RAM. And so some of those places are things like what was the last known velocity of a certain like extended sprite, which is like, for instance, when an Yoshi eggshell breaks, it creates these 4 little eggshell fragments, and those have velocities. And so whenever whatever that value gets set to, that's important. That actually gets used to determine what happens during the glitch. The long and short of it is, if you manipulate enough of those values, you can get the game, the processor, the Super Nintendo's processor, to start executing instructions not from the game cartridge where it normally would run code from, but rather from RAM, which is where all of the game state is stored in RAM. And in the credits warp, historically, the way it's worked is we have basically killed Koopas at specific x coordinates, so that there's a table in memory that one byte after another stores the different x coordinates of the different sprites, things like Koopas. And so if you kill Koopas at certain x coordinates, you can set up this table to have several contiguous bytes of whatever memory you want, and you can make it look like code. And so when the processor runs this code, you can make it run the code that says play the credits.
So when you first did your first ever run of the game, it was about like 6 minutes and 40 seconds or something. And I think now the world record is down to something like 40 seconds.
Yeah, it's like around 41.
Yeah, it's so how has that the route of credit swap evolved over time, and like how have people been able to shorten the route so much?
Yeah, so there have been several like major breakthroughs. The original route by Jeff W356 was like relatively slow because of the particular memory addresses that you needed to manipulate. And it involved things like you need a throw block, one of those blue blocks that you can pick up, and you had to break the throw block at a certain place and with certain timing. And that was just like inherently slow to get to that point, get the throw block, get it in the right sprite slot, break it in the specific place where you needed to break it, all that stuff.
Yeah.
So some of the improvements early on were things like breaking the throw block in a different place, or I figured out actually when I figured out a like faster method to get the cloud using that charge and chuck item swap. Um, Part of that also figured like drastically changed the way that the code, like the processor executed instructions during the glitch, and so you could start looking at different memory addresses that you needed to manipulate. And it turns out that uh, the just the way that that whole change worked, the change in execution of the item swap worked, it allowed you to manipulate the things you needed to manipulate using stuff that was readily available in the first half of the level. Things like you need to have Yoshi shell break on screen at a certain
Mm-hmm.
location, or you need to just like bounce on an enemy at a certain location on screen, that sort of stuff. That was all pretty easy to manipulate a lot earlier. And so at that point, the world record was ended up being around a minute and 15 seconds, and that was like you needed to like I said, break the eggshells at a certain place. You needed to like uh, jump on a shell or kick a Koopa shell at a certain place, but it was like pretty simple stuff. And you also had to kill the Koopas at certain X coordinates. And that's what took up probably most of the time in terms of the setup. You needed to get that arbitrary code into memory so that the
Mm-hmm.
processor would execute it and it would run the credits.
So the
The
end, oh, sorry.
Yeah,
So the end of every run is basically just doing the item swap and then running the credits or the
yeah,
information that you send to the process. Okay, that's cool.
right. Yeah, so you would set up all the RAM addresses you needed, including that sprite X coordinate table. You would
Mm-hmm.
go do the item swap. The item swap would execute the glitch, which would run all that code and immediately play the credits. Yeah,
So
so
how is
that's
it? How is it discovered that like, I feel like you keep saying that you change something. Um, but when the first trick was first discovered, and it's been evolving over time, do people use ROMs and stuff to figure out what bytes are being like programmed or processed in the SNES?
most of the work is done in emulators. Emulators have really good tools these days for not only seeing like what's in RAM, like what values are
Mm-hmm.
contained in RAM, but also you can see specifically what instructions are being run by the processor. There's like I think up to like maybe like a million instructions per second that can be
Wow.
run. But you can log all of that and then look through it and see what's happening, see what memory addresses the processor is actually looking at to determine what it's going to do when you get to this like glitched out state. And so if you can see what memory addresses the processor is reading, you can try and figure out, well, if I manipulate that memory address in this way, what'll happen, or what about this way? And it's a very like research heavy process. You need to try a lot of things and be very open minded in terms of how you can actually manipulate the memory you need to manipulate, that sort of stuff. Um, it took a lot of time to find these improved setups, and this was a lot of research that was
Mm-hmm.
basically like akin to security research in today's terms. It was like how you would find an exploit in Windows or in Chrome or whatever,
Wow.
and create a virus or something like that. I will point out though that I didn't. So I was talking about the version where we had to kill the Koopas at certain X coordinates and then do the item swap. So that was the minute and 15 route. We got the time down
Yeah.
to around 41 seconds. The major breakthrough there, that was also my work, uh, was instead of running code from the sprite X coordinate table, I figured out a way to run code from it's called the joypad auto read registers. There's basically 8 bytes in a row in memory where the game reads the controllers every frame. And so if you have two multi-taps plugged in, and multi-taps are devices that let you plug in extra controllers essentially. You can have 4 controllers plugged in, and you can set these bytes of the joypad auto read registers to not quite whatever you want. You can't press left and right at the same time. There's certain like kind of non-existent buttons in the controller, but you have enough control that I was able to figure out a way to get it to play the credits just off those bytes of code from the joypad auto read registers. And that was the big breakthrough that allowed you don't have to do any X coordinate table manipulation really anymore. It was just like you set a few different memory values and do the item swap, and that's it.
Wow. So what does the future hold for this category, zero exit? Do you think that's gonna be able to push any lower? Are there any maybe new routes that could be discovered that save time, or is
it's
this
really
is
hard
this
to
where
say?
It's gonna end?
It's super hard to say. There are some like constraints that make me think that it's going to be hard to push it lower. Like there's just not a lot of time. Like you have basically the earliest way that anybody knows to crash the game or like do anything that might run arbitrary code is to do that item swap. So you have to get far enough to the level to do the item swap. That takes like the earliest you can do that is maybe like 34 seconds into the run.
Yeah.
So you have about a 7-second leeway to do whatever other manipulation you need to do to set up memory. The one improvement that I think might be viable, like that I could see very easily could happen, is that the current route requires Mario to be at a certain X coordinate during the item swap, during the glitch that runs the credits. And being at a specific X coordinate during that is very hard. It's like super precise while you're moving.
Mm-hmm.
It's very hard to set up your X coordinate to a specific pixel perfect value. Mm-hmm. But with different like controller code, pressing different buttons on those extra controllers, it's possible that you wouldn't actually have to have that pixel perfect. Like I've done a bit of research and I haven't found a way to make that happen yet. And honestly, I'm really the only person looking into this, so I'm probably the only one who will find it anytime soon. Mm-hmm. And I'm not working on it right now, but that would be the one major improvement, and that would make the run a lot easier, and it would make it a little bit easier to put in some optimizations that might make it a little bit easier to beat the current time. Because like as it is, I only complete like 1 in 500 runs or something like that. Yeah. It's like insanely hard right now.
How much actual gameplay is there? Because I know at the very beginning, when you first like load up a level, it's like, oh, it does like a little screen that says, oh, you have to, go save Princess Peach, go quick or whatever. Yeah. So like, how much actual gameplay? It's like 15 seconds, right? Like the actual startup is like 40 something seconds.
The joke that I would always make is, oh, I'm more than halfway into the run and I'm on world record pace, because you do enter the level with a little bit more than half of the like time on the run remaining. So that is like, but you just like start running to the right at the beginning of the level, and by the time you get to like anything that you could mess up, you're more than halfway to the time of the world record.
I love that joke. It's because like in SMB1 when you do like flagpole glitch, you're like, guys, we're on world record pace. This is insane.
Yeah. So it's about 20 seconds of gameplay. Like a fair amount of that is just holding right or whatever. So you could trim off a fair amount of that, but like there's just not a lot of leeway to do anything differently than what the world record is doing currently.
Yeah. So if somebody is interested in zero exit and they want to learn how to do it, maybe not, get world record, but just do the trick, are there any resources like documents or videos that they can watch or read that could help them pull off this trick?
Yeah, I actually did a lot of work putting together a newbie-friendly version of the run, where basically you can take your time with most of the things that, in order to get world record, you have to go very fast. But if you just want to get the credits warp, you can take your time with a lot of the stuff. There is still a hard part. Getting that item swap is still pretty hard for newer players, but I have some resources to help you practice that and learn how to do that. So you could just Google like SethBling credits warp newbies, and you'll get there. You'll find the video. There's a video. There's a Google Doc that explains everything you need to know. and that has also some links to some other resources for help practicing.
So when I decided that I was going to do a podcast with you, I watched some of your videos about, zero exit and some other like tricks that you can do with arbitrary code execution. And there was one that I was really interested in. It was 11 exit, but you warp to the very end of every single level like as soon as you entered it. So how does that work? Maybe you don't have to like explain exactly how, but just in general, what are you doing in that video?
I really enjoyed working on that project. So let me just quickly like explain what it is.
Mm-hmm.
So 11 exit is the category where you go through Star World and then go to Bowser's back door and then beat Bowser. In normal 11 exit runs, even after Credits Warp was discovered and people were doing runs, 11 exit did not ban arbitrary code execution. And I decided that it should be banned, and that in order for it to get banned, I was going to have to do an 11 exit run that involved arbitrary code execution. And so at the time, basically we thought of 11 exit as you have to beat all of those 11 exits and get to Bowser's castle and then kill Bowser. Yeah. And glitches were allowed. The cloud glitch is a pretty big glitch. But anyway, so I worked with a couple other people. Mr. Cheese was really big in this. But basically the idea was we ran an arbitrary code execution glitch several times in order to write, I think it was like 6 bytes of values into memory. There is, in Super Mario World, there is like a region of RAM that actually contains some code that gets run every frame by the game. And so you can modify this code that gets run from RAM because it's RAM, and you can write values to it. And so I wrote, I think, 6 bytes into that area of RAM so that every frame it would like run my little cheat engine, essentially. And so what this cheat engine did, without getting too technical, is by pressing buttons on an extra controller that was plugged in, you could do various things. So one of the things you could do is you could instantly beat any level with a normal exit. Another thing you could do is instantly beating a level with the secret exit if you held down different buttons on that controller. You could do this thing where you would like turn Mario invisible, but he also couldn't take damage. And so I actually use that in Bowser's Castle. You can't just beat Bowser's Castle like the normal exit way. It won't play the credits. You have to actually get to Bowser and kind of kill him. Anyway, so I had to go through Bowser's Castle. So I did one that would like let me turn Mario invisible and turn off his hitbox or something like that. So that he wouldn't take damage running over spikes. And there's another one that let me like glitch out the crushers in door 5 of Bowser's Castle, and then a final button combination that basically instantaneously kills Bowser. And so you spend like 5 minutes or something setting up this glitch, but then you get to just cheat your way through the rest of the game. You still have to go through Bowser's Castle, but like you get to cheat your way through a lot of like every room essentially at Bowser's Castle, and then yeah, you beat Bowser instantly, and it's pretty silly. I submitted this to one of the GDQs and it got rejected. It made me sad, but it would have been. It was basically it was like only slightly faster than a normal 11 exit run because of all the time you had to spend doing that arbitrary code execution setup. But yeah, when I finished the run, I was like, okay, guys, I did it. I beat the 11 exit world record. Should I submit it to the leaderboard? And they're like, hold on, we'll ban Ace. And so that's how Ace arbitrary code execution got banned from the 11 exit category.
How long did that like figuring out all like the stuff to do for 11 exit for that run? How long did that take you? Because it seems like it would take you a while to think of like your little cheat list, basically.
It wasn't that bad. I think it probably took like a few days of like research and testing and stuff, because I think I did that one after I had done my Flappy Bird code injection, which we used a lot of similar techniques. No, that was before it. That was before Flappy Bird. Never mind. I don't know. I don't remember. I think I had already done some projects with like similar techniques is the point though. And so I kind of like had a pretty good idea of what I needed to do to make it work. I think it was after Flappy Bird.
So you mentioning Flappy Bird. So
Yeah.
what are like I'm assuming that's something in Super Mario World, right? So what
Yeah.
are some cool like stuff that you've done with arbitrary code execution and running the code and stuff? What are some
Mm.
cool like little projects that you've worked on that you want to share that
Yeah,
are
so there's a
cool?
couple. Well, the Flappy Bird one was a good one. That one was
Mm-hmm.
like a pretty big like first for a person on a like a person doing the type of thing that TaskBot would normally do.
Mm-hmm.
So Flappy Bird was a code injection that I worked on with P4+2. So he wrote all the code. It was like 300 some odd bytes, 321 bytes or something of code that we injected into RAM and then ran as like code,
Mm-hmm.
and that basically turned Mario the game into Flappy Bird, and you could play it. And we got to reuse a lot of stuff from the game, some of the physics, and I don't know
Mm-hmm.
about the physics, but we got to use the pipe graphics, and
Yeah.
it made Mario look like he was flapping. It was very cute. Um, and that was all done by hand using arbitrary code execution, like I'm talking about.
Mm-hmm.
Um, we used had extra controllers plugged in and stuff, but and like with buttons held down. But and then I think the like coolest project that I've worked on was the jailbreak. So this guy named Cooper Harrison came to me with a glitch that he'd found that basically if you corrupt the save data that is stored, it's stored in the Super Mario World cartridge has some RAM inside of it. It's battery backed RAM that's used to store the save data.
Mm-hmm.
And if you corrupt the save data in just the right way, you can get the game to run arbitrary code when you load the save file. So basically, he figured out a way that you could corrupt save file C so that when you or like try and load save file C, it would run arbitrary code,
Oh
and you
wow.
can store that arbitrary code in the cartridge. And so
Mm-hmm.
you can basically have this like permanent jailbreak that's installed on the cartridge itself that allows you to do stuff. And so I wrote a hex editor that basically allowed you to play the game and like view and edit memory in real time. So you can like change Mario's power up state, give him feather power or even invalid power up states. You can beat levels instantaneously by editing certain addresses. You can change a lot of stuff. Um, and you could also like read the ROM. Like you could go page by page, reading the ROM in hexadecimal, copy it to your computer, and you would have a functioning ROM that you could run in an emulator.
Oh wow.
So, and that was really cool because it's stored on the cartridge, and to like load it up, you don't have to do any like speedrunning glitches. You just load save file C. And we even came up with a process to copy it from one cartridge to another, where you would run some code while you have the jailbroken cartridge plugged in. That code would copy a bunch of data into unused RAM, and then if you could pull out the one cartridge and then put in another cartridge without powering off the console, then that code would still be in unused RAM, and by doing the item swap setup, you could run that code that would install the jailbreak onto the new cartridge. It was like pretty fast to copy it from one
Mm-hmm.
cartridge to another that way.
So is this is this a ROM hack of a Super Mario World, or is this technically still vanilla?
It's not a ROM hack. A ROM hack would require editing ROM, which is ROM
Mm-hmm.
stands for read-only memory. You can't do that with a cartridge. It's burnt
Yeah.
into the silicon in the cartridge. So no, it's not a ROM hack. It's vanilla SMW. It's just a modified save file essentially.
Oh wow.
Yeah,
That's cool.
and
So right now,
yeah,
oh,
it
sorry.
also allowed you to. I just like remembered that has more. It
Mm-hmm.
also allowed you to like kind of mod the game by having like adding a plugin that would run every frame, and so you could have the plugin do things like change the physics of the game. Or I wrote one for a super scope, a plugin that would make the super scope work, so you could shoot enemies using the light gun, the Super
Yeah,
Nintendo light gun.
that's fun. So right now we're
Yeah.
only talking about things like humans have pulled off and everything. But are there any really cool arbitrary code execution things that are only tasks have done so far that are really cool, or just like
There's a
need to
ton.
show off?
I mean,
Yeah.
there's you look at the GDQs always get the coolest stuff, but they've done
Mm-hmm.
like they've basically been able to live stream video from a computer to a Super Nintendo, like and audio, video and audio. So they were able to like play back a video of Super Mario 64 speedruns on a Super Nintendo, things like that. There's been
Wow.
crazy stuff. You just Google, TaskBot GDQ, you'll find
Hmm.
there's hours of like crazy, ridiculous content there. It's awesome stuff.
Yeah, so lately you've been branching out into some other games other than just Super Mario World. Um, so how similar is like learning Super Mario World compared to learning like basically Zero Exit for like Super Mario Land? I think you did one, or Super Mario Bros. 3. How similar are they? Like in difficulty and also in like how they work.
Yeah, so I've learned a few different credit swaps recently. Super Mario World, obviously, I've known for a long time. Super Mario Brothers
Hmm.
3 is another game that I learned a year or two ago. Super Mario Land 2 has a credit swap that I learned recently, and Yoshi's Island as well. Uh,
Hmm.
so Super Mario World, Super Mario Brothers 3, and Yoshi's Island, those credit swap all work like somewhat similarly to each other. They essentially are all like use a glitch that runs code from RAM and then set up the sprite X coordinate table so that it like contains some code for the glitch to run.
Hmm.
Super Mario Land 2 works very differently, and it's actually super cool. Um, I'm going to recommend a video by Retro Game Mechanics Explained. If you just Google Retro Game Mechanics Explained Super Mario Land 2, you'll find the video. Uh, but it shows how the credit swap works in that game, and it's awesome. It's like a visualization of what's going on in memory of that game, and it's really cool. It's pretty fun to just like make like you're physically kind of running and moving through memory.
Hmm.
It's like hard to understand what I'm talking about, but go watch that video. So
Hmm.
that one's pretty different. The other three games that I was talking about, though, they're like pretty similar to how they work to Super Mario World in some ways, but of course they all have their own physics engine, and like Mario can do different things, Yoshi can flutter, like so learning the physics of Yoshi's Island was like pretty different from playing Super Mario World. Learning how to do the credits warp was actually not that different. It's a lot of like using RAM watch tools to look at RAM and make sure that you're getting the right value when you do the setup. There's a lot of like pixel perfect stuff that
Hmm.
involves basically checking where is Mario or Yoshi or whatever relative to the ground. You can see the pixels on the ground. You can see the pixels on Yoshi or Mario. Are they like lined up in a certain way? If they are, then like this setup will work. So that stuff was pretty familiar to me, and I took to that pretty fast. There's also a lot of the skills there involve inching your way pixel by pixel to be standing in the right spot to do these setups. And I've like over time mastered the art of pressing left or right for a single frame or one or two frames in order to be
Hmm.
able to inch your way into the right pixel. Um, so there's some similarities. There's some pretty big differences too. Yeah.
So this is kind of an off-topic question, I guess, but what TV or how are you playing the games? Because if you need to inch yourself to an exact pixel, and if you're one pixel to the left or the right, it doesn't work. You must be using some sort of TV or ROM or something or emulator so you can see in each individual pixel. So is that the case, or is it kind of a mishmash of pixels?
So yeah, for sure, emulator makes it the easiest to see the pixels, but I don't do
Hmm.
runs on
Yeah.
emulator. The latency involved in an emulator makes it, I think, hard to do a lot of stuff.
Hmm.
It's
Yeah.
just like slows you down, and it makes things more error prone. I actually did start out on a CRT when I was doing credit swap. For a lot of the early credit swap stuff, I was using a CRT, and in fact, I remember we had a credit swap race at AGDQ
Mm.
2016, and that was a four-way race. And I remember going around to every CRT I could find in the practice room to find the crappiest ones and make sure I could still pull it off. And like those things don't render pixels very well. Like they're not clean
Yeah,
at
they're not too
all.
good. Hmm.
Um, but when you've done a lot of it, your brain can sort of pick out like, yeah, the like I can't see the individual pixels, but I can just tell like it's not
Hmm.
lined up right, or it is lined up right. It's kind of like amazing what the brain can do in terms of like matching those patterns. These days, though, I do use an LCD screen. I have a monitor. It's a 1080p monitor that has a very low latency. I do you want me to say what brand or anything, or just leave
I
it
don't
at
mind
that?
if
Okay,
you want.
it's Asus VG278Q. It's 144 hertz, which doesn't really matter for speedrunning a 60 FPS game, but the input latency is extremely low. Or display latency is extremely low, and so I personally like don't really notice a difference in terms of latency between a CRT, which is ultra low latency, and this LCD. I do also have a FrameMeister upscaler, which is a hardware upscaler that takes the analog signal and turns it into a digital signal.
Yeah.
And so that is also very low latency, and so I end up with, I think, less than a frame of latency probably. It is expensive hardware though, but
Yeah, it is.
it gets the job done. I have a pretty clear picture when it gets to the LCD, and I can see the pixels pretty clearly in this setup.
So going back to the arbitrary code execution in the games, you've taken those, like, a few games and you've put them together back to back, like a multi-Mario marathon kind of. So what was the motivation behind that, and like kind of what is that about?
Yeah, so Darbian was the original guy to and of course you know this to do the hour Mario challenge. It's called the Mario Hour. And the idea was he picked a bunch of popular speedrunning Mario games, basically the first 6 games excluding Game Boy from the mainline Mario series, and speedran them all in under an hour. And he spent a while. I think he spent about a month before he's able to finish a run. You yourself have done runs, and you're trying to get the world record in this, right?
I am, yes.
So Mario Hour was the motivation. So I basically looked at Mario Hour and I was like, well, yeah, but what if you used credits for it? And I talked to Darbian about it, and he's like, he had some interesting thoughts about it. Basically, he was thinking like, you could use credits warps, but then like it would make the whole challenge trivially easy. I mean, assuming you could complete all the runs, it would make it very easy because it makes everything go so much faster. Super Mario Brothers 3 and Super Mario World would shave like 20 minutes off the run or something because of that. And so he talked about like how he considered doing it, how there's another credits warp in Super Mario Land, and so he was thinking like maybe you could add Super Mario Land 1 and 2, but then it would still be like the timing would still be pretty easy. So I added Yoshi's Island also because it has another credits warp. And so basically I also decided to remove Mario 64 because I kind of thought it was the odd one out. It's not a 2D Mario game like the rest of them. And so with all this rejiggering, it's a little bit of a different thing. It's not really that comparable. You're using credits warps. You're playing the Game Boy, a couple of Game Boy Mario games. You're not doing the 3D Mario 64. I'm calling my version the Mario Credits Hour because it involves those credits warps. It's 4 games run normally with warps, and then 4 games using credits warps.
Wow.
So I finally finished learning Super Mario Land. That was the last of the 8 games I needed to learn in order to do this whole thing. So it's from here, be a lot of practice and de-resting in order to be able to do that, all 8 games in under an hour. But I did complete a subset of this run, which I called the Mariflow Challenge, as a horribly named throwback to the Mario Hour Challenge. And the Mariflow Challenge is all 4 credits warps in a row in under 15 minutes. And I was doing them in release order. So it's Super Mario Brothers 3, followed by Super Mario World, followed by Super Mario Land 2, followed by Yoshi's Island. So those are the 4 credits warps, and I was able to complete that in about 14, and it was under 15 minutes. And then the remaining 4 games in the hour, the Mario Credits Hour, will be Super Mario Brothers 1, Super Mario Brothers 2, J, Japanese, Super Mario Brothers 2, U, US, and then Super Mario Land 1.
So I guess to end off our conversation with like Ace and Mar 15 hour, or Mar 15 minute, I guess. I don't know what I was gonna say. I completely lost my train of thought there.
That's no problem.
All right, so I guess moving on to something else that you've been working on, you also have been doing a lot with machine AI and machine learning and everything. And a while back, you created an AI that would that know nothing about a game and then would beat a Super Mario World or a Super Mario Bros. Level. So what I guess was the inspiration behind that, and how does the actual AI and machine learning work?
So the inspiration back then was I had taken some machine learning classes in college and done some machine learning projects. I had never done anything with genetic algorithms. Genetic algorithms are a kind of a class of programming algorithms that use something like real life biological genetics.
Mm-hmm.
It's usually a simplification, and so I thought it would be cool if I could use a genetic algorithm to try and beat a Mario game. I found a paper online by somebody who had basically came up with an algorithm that would genetically breed neural networks, and I thought it was a cool paper. And so basically, I spent a couple days re-implementing the paper and applying it to Super Mario World, and the basically I ran it, and eventually after after enough playthroughs, the AI was actually able to beat a couple levels. Um, and yeah, then I tried on a couple other games, Super Mario Brothers 1 and Super Mario Kart, and it did okay.
Mm-hmm.
Did okay. Yeah.
So when you think of the idea, like, oh, okay, I want to make an AI that will beat a Mario game, how long does it take from that initial, thought, oh, I want to do this, to the actual execution? How long does that take? And while you're doing the process, is there a bunch of planning that is involved before you actually start doing the code? Or you just kind of hop onto the code and just kind of start working on it right away?
Uh, I mean, it varies. It varies drastically
Mm-hmm.
depending on
Yeah.
what kind of project I want to be doing. Like I said, for the Mario one, the genetic neural network algorithm probably took about 3 days to implement the first version of, and
Oh,
have
wow.
something that could actually like progress through a level and learn how to beat a level. Um, I've worked on a couple other projects, and those have taken significantly longer. I mean, sometimes I need to learn a whole new framework, like TensorFlow,
Mm-hmm.
um, or I mean, I learned some new algorithms, some new machine learning algorithms, reinforcement learning algorithms, that sort of stuff, and like that's a lot of like reading and looking at other people's code, and um, that can take significantly longer to get everything all set up in the right way to actually get it working. Uh, weeks or a month.
So, have you ever been like working on a project and you think it's all done, you've done a lot of planning, everything, and then it just doesn't work, or like it doesn't work as well as you wanted to? I guess.
Uh, yeah. Usually it's not. I don't usually like the way that I code and the way that most like, professional type software people code
Mm-hmm.
isn't that they like write a whole project and then hit run
Yeah.
and
Uh-huh.
then like see if it works or not. You do a lot of tests along the way.
Mm-hmm.
Basically, I usually spend the beginning of a project looking for like what are the things that I don't know if they're going to work, and just like try and make sure that I understand, can I solve that problem? Will I be able to find a way to solve this, make it work, get the API that I need to run. So I usually, if a project fails, I'm failing pretty early in it. But I've for sure had that happen a lot. I like spent years wanting to make a Mario AI using like a real machine learning framework and failed because I couldn't get the various frameworks running. You have like it's actually pretty involved. You have to set up your GPU just right and get
Mm-hmm.
certain software that can use your GPU for to run neural networks, and you have to get other software to work to like use that software. Anyway, it's a pretty involved process, and I've definitely failed at getting that to work several times. But like I said, it's usually very early in the process. It's not like I've written
Mm-hmm.
a whole AI and then
Yeah.
it doesn't work.
Good bird. So the same AI that you're using, is it used for anything else like in the real world, or is it used by humans in any way? Because I think you said, I think I watched the video and it said that you're using um, like some sort of like the breeding. Basically, they'll produce the best round, I guess, when they get like the most points and when they go the farthest, and then over time they get better and better and better. So is that used by any other AI in the real world for like different applications, like maybe driving cars or something like that?
I wouldn't say I'm like an expert in knowing what all is out there, but I
Yeah.
have looked into it a little bit. Genetic algorithms, especially with neural networks, are not used super frequently in like real world applications, to my understanding. The thing about genetic algorithms is they mimic evolution, and the thing about evolution is it's had a long time and a lot of resources. You know, you have billions of organisms all participating in genetic evolution. It's real slow. It takes a lot of resources, and to simulate that is also very slow. And it's like a very understandable process. It's like it's cool how it matches our own, you know, how we evolved, but it's not really a great way to get something useful, to be honest. But it was definitely fun to work on. Um, the other projects that I've done are much closer to things that are used in the real world. So Mariflow is a project I worked on that basically trained by looking at me driving. So Mariflow, I basically spent hours just playing Mario Kart, and then I wrote some code that would train a neural network to try and predict what I would do in any given situation and just mimic that. And so then I let it run, and hopefully, you know, if it's mimicking what I would do well enough, then it hopefully will go through the course and finish. But it like Mariflow didn't want to finish the course per se. It just wanted to predict what I would do. So the better the driver that you get for like the training data, the better the neural network will learn theoretically. And that type of machine learning is used all the time. That's like one of the most basic. It's like one of the first things you learn about in machine learning classes. It's called supervised learning. You have a goal, you know, like what you want, and you're just trying to like train a neural network to mimic the existing data or understand the existing data. The other big one that I worked on was called MarIQ. It was called MarIQ because it used something called Q learning, which is a type of reinforcement learning. Reinforcement learning, you can think of like giving a dog some treats. You're reinforcing positive behavior, and you can also reinforce negative behavior by, you know, scolding your dog when it does something bad, pees on the carpet. So reinforcement learning works the same way with an AI that's trying to learn how to play a video game. If it's playing Mario Kart and it, you know, makes it through the course, you give it some rewards. You say, "Good job, do that again." And if it, you know, turns around and drives backwards, or it falls off the course or whatever, you can say, "Hey, that's bad. Don't do that." And so that's how MarIQ worked. And it had Q learning is like a specific algorithm that uses those reinforcement signals to train a neural network. And so that one, like Mario, like the genetic algorithm, that one also learned on its own. It didn't try and mimic a human. It didn't know anything about how humans played the game. It just tried things and saw what gave it rewards and punishments, and adjusted accordingly. And so Q learning is something that's sort of starting to make its way into real world application. You can look up, I can't think of what it's called. Google has done a bunch of work with Q learning to train AIs to play various games on Atari, and those AIs get better at those games than a human does. Yeah, there's various applications of Q learning in the real world, and I don't know if it's like, I mean, that's sort of academia, I guess, right? It's not really being used for anything. Like, it's not necessarily like driving an actual car.
Mm-hmm.
But I think it is like that sort of technique is starting to make its way into the mainstream, and maybe it is being used for some part of how to drive an actual car.
Mm-hmm. So MarIQ and Mario are basically doing the same thing, where they don't know they know nothing about the game, and then their goal is to beat the game. So Mario Kart and Mario or Super Mario World are completely different games. But how similar are the actual programs or the actual AIs? I guess
the AIs are extremely different because, like you said, they're totally different games. They're receiving different input signals. Like they get to, I mean, they kind of have a set of eyes that they can see the game with. You have sensors that like say, okay, well, how is the level laid out around me right now? Both in the terms of like how is the track running in front of me for Mario Kart, and or like what enemies and platforms are on screen right now for Super Mario World. I will say that like I think in general the types of AIs that I used are much better at learning something like Mario Kart than they are at learning Mario World, because a single small speck on screen can represent an enemy in Mario World, and like an enemy can kill you. Whereas in Mario Kart, it's much more about like observing the whole playing field. Like this area of the screen is track, this area of the screen is dirt, this area of the screen is lava. Like avoid the lava part of the screen really, strongly, maybe avoid the dirt part of the screen, try and stay on the track, right? So it's like I think a lot easier, and that's why I chose it for my later projects, Mariflow and Mariq. I think it's a lot easier for an AI to learn how to do that than it is to like jump to avoid enemies and time time things like that in a Mario game.
So you said that the AI for Mariq, for the Mario Kart AI, that it can kind of see. What do you mean by it seeing? Like, does it see what us humans would see in the game, or does it see something like a more broken down, more simplified version of the track?
It's a little bit simplified. It's kind of like if you saw like a 15 by 15 pixel grayscale version of the game. That's kind of what it sees. Just because the fewer inputs that it has, the faster the process will run. But like it'll learn faster. You can actually like run the AI faster. It just speeds up the whole training process. It'd be nice if it could see more like at a higher resolution, but it would just slow everything down more, and it would end up taking a lot longer to get a usable AI.
So you said, I think earlier you said something about reinforced learning, how like, if the AI gets farther on the track, or if it gets farther on level, that it gets rewarded by something. How did you implement like that reward system, I guess, in Mario Kart? Because I know in Mario Kart there's like invisible like markers and stuff that the game uses. So did you like kind of use that as a reward system, or did you kind of recreate your own or something like that?
Yeah, I actually did use that. Yeah, that's exactly right. So so the track is broken up into like areas, and each area basically like the first person to reach an area is in first place, and then the second person to reach that area is in second place. That's how the game tells who's in what place. And there's about like 30 to 40 checkpoints per lap in any given course. And so basically anytime that that Mariq, that the cart would cross from one area into the next, I would give it a reward. And if it ever crossed from the next area into the previous area, I would give it a corresponding penalty. And so it was trying to basically accumulate the algorithm. The Q learning algorithm was trying to accumulate as much reward as fast as possible. And so going forward on the course faster would give it more reward, and that's what it would try and do.
So when you created these AIs basically throughout Super Mario Kart and Super Mario World, which is also compatible, I guess, with SMB1, was there any glitches, tricks, or anything that surprised you that the AI would discover or didn't do, maybe?
Yeah, actually, I ran the stream running I left the stream running for a while just like to watch, and it did actually end up like clipping into the ground in one of the levels, I think.
Oh wow!
Mario like clipped into the ground, and that's just like a glitch in SMB1, but it's pretty rare. It's like pretty hard to even make that happen on purpose. That's kind of reveals one of the benefits of something like this. Like the algorithm is not going to learn how to play really better than a person will, like a speedrunner, because we can engineer things, we can think about things, but you can have it try things and have it like just throw so many like hours of gameplay at it that eventually it might just find a cool glitch for you, and it'll just try different things, and maybe you'll find something cool because of that.
Do you have any other AI projects you may want to work on in the future, or that you've scrapped because they're either too difficult or you just haven't gotten around to making them?
I don't have any specific plans that I like will follow up on anytime soon necessarily. I've always wanted to scrape a bunch of Mario Maker levels from the Nintendo servers and then train an AI to like create a Mario Maker level based on this giant database of basically mimic the levels that people create and make its own terrible level.
That's cool. Okay. So
I think
I
it'd be really
think,
interesting, but it's like
yeah.
there's challenges with getting that data and actually
Hmm.
using it. So
I mean, how would you even attempt to like scrape, I guess, the levels and stuff off Mario Maker 2? Because that seems like a really
I
hard thing
haven't
to
I haven't looked
accomplish.
into it, but I mean theoretically, a console plays levels. It needs to be able to request a list of levels from the server and get the
Hmm.
data from the server. So theoretically, the infrastructure is there for a client to download a bunch of levels from a server. I don't know. I don't know how hard that is to do en masse, though. That's definitely one of the open questions for the project.
So I think we're gonna close off the stream. The last question I want to end on is, now that you're learning some more games, you said for the 8 game Mario Marathon, what's your plan after that? Do you have an idea of what you want to do, or you just kind of gonna wing it after that?
Kind of gonna wing it. This has
You're
sort
gonna
of
wing
been
it.
how I've run my YouTube and Twitch channel throughout its history. Is
Hmm.
I'm always kind of working on the last thing that I have planned, or like, oh, I make a video. Oh, that was my last idea. I hope I come up with another one. So I never plan very far ahead. I do actually. Getting back into machine learning does sound pretty appealing, but like I said, I don't know that I have any specific goals. I think it's going to be more of just like look around, see what's out there, see if I can come up with any cool ideas.
Yeah, I totally get winging it because like right now I'm so focused on trying to go for world record for Mario Hour for that category that I'm like, once I get it, I don't know what I'm gonna do next. What
Mm-hmm.
new goal is there to try to get? It's
Yeah.
it's hard.
Yep. I feel that.
Yeah, so I think that's going to be it for the questions that I have for today. I might think of something else, but I think that's going to be it. So I think we're going to move over to a Q&A. If anyone in chat, either from your chat or my chat, has any questions they want to ask SethBling, could let us know now or in a bit. But
Sounds good.
yeah. What got you into AI? I guess I'll just start with that question. Why not? Like,
I
did you
took
take a
some
class?
classes in college. Yeah.
Hmm.
Yeah. I have a degree in computer science, so that was sort of part of. I mean, it wasn't like a required class for the degree or anything, but it's always been an interest of mine. Um,
Mm-hmm.
the class was pretty cool. Like we learned a lot of basic machine learning techniques, and then for the first term, and then the second term, we actually, as a class, took on what was called the Netflix challenge. They had a $1 million prize for if somebody could like improve upon their like recommendations algorithm. So they had a giant database of data, of like user preferences,
Mm-hmm.
and you were supposed to submit, like you would like come up with your own machine learning algorithm to like look at this data and try and give good recommendations. And so we as a class tried to try to win the $1 million, but we didn't.
Yeah, that sounds tough.
Yeah,
Sounds fun though.
it was very fun.
So,
I think Netflix has had some more recent challenges too, of like something about like what like what shows they should produce or something like that. Something interesting.
I know that some companies have done something like that. I think Google like made like a fake like server or something that they said, hey, if you can hack into this like database, that will give you like $100,000 or something. Because
Mm-hmm.
they were saying like,
Yeah,
oh, is this good enough so that people can't hack into it? And if someone could, they'd get a
yeah,
lot of money, and
yeah.
that's cool. Uh, Somebody asked me if I'm ever gonna try Seth's Mario or Credits Warp challenge, and I don't know. I might. I've attempted to go and learn the Super Mario World Credits Warp. I just haven't really spent that long on it, and
Mm-hmm.
I haven't done it yet. But maybe one day.
Yeah. It's if you can do the item swap, honestly, the rest of it is just like, and just figuring out how it works, which is not that hard, and then
Hmm.
memorizing. You don't even have to memorize it.
Yeah.
Memorizing all the pixels, but yeah, I think you could probably learn it in a couple hours if you can already
Hmm.
do the item swap.
My problem was that I think either I forget what happened. It was either I waited too long and the Koopa that I was holding, the Koopa shell, the Koopa would come back to life and then kill me,
Uh-huh.
or I would run
Yeah.
out of time. Like since there's a
Hmm.
time in level,
Hmm. You
but
can also
if I
pause, like that can help
that's
with
true.
that.
Yeah, that would definitely help.
Yeah.
Um,
I think Super Mario World is. I think Yoshi's Island is a little bit harder to learn than Super Mario World.
hmm.
SMB3 is not too bad, and neither is Super Mario Land 2.
Yeah, Super Mario Land 2 seems the easiest out of all of them because it's
I
like
think
the
it is.
easiest
Yeah,
because you like go down a pipe and then you exit the level while you're still in the pipe, and
yeah.
the game is like, what the heck, you're not supposed to do that, and it
Getting
kind of.
through the rest, getting through the garbage that is like memory, like
Hmm.
moving through that is also like it requires a little bit of learning too, but it's not too
Hmm.
bad.
Gavin asked, how long did it take you to learn Flappy Bird? So I guess that means how long did it take you to either like run the code and also like think about how the code's gonna like actually work.
Yeah, so we spent several weeks planning that. Like P4 Plus 2 had to write all that code. I had to work a lot to figure out what the process was going to be to actually like inject all that code. Um, and so yeah, we spent several weeks planning, and I also spent like a couple days doing like full practice runs. I kind of acted like it was the first time I'd ever done it on stream, but
Hmm.
I had done several full practice runs off stream, and it was, and it's like an hour long. Like a
Oh
practice
wow.
run's like an hour. So yeah, it took a little while, but I did refer to notes during the thing. I didn't have to memorize it or anything. Um, the notes were very helpful.
Was was that like if you messed up one input or like if you threw a Koopa 1 pixel too far to the left or right, would that mess up the whole thing, or was there so many that it was like it was okay to do that and it
No,
wouldn't mess up
well,
everything?
most of it. Uh, if you messed up anything, it was going to crash the game.
Oh
For the
wow.
first like 15 or something minutes while you're kind of setting
Hmm.
up the actual code injection, um, any mistake is going to crash the game. Once you get to the part where you're actually injecting the Flappy Bird code en masse, I think we had a procedure through which we could actually kind of like go back and overwrite some bytes. I think it was more like we could loop around back to the beginning. So if I made any mistakes, I would have had to start over. Later, for the jailbreak, um, I actually figured out a better procedure that was like I could just fix a single byte if I noticed that I made a mistake. Once I got to that code injection part, and that because that was a very similar thing. I was writing 240 or 250 bytes or
Yeah.
something of code. So it was a very similar procedure, but I'd improved it by that point so that if I did make a mistake, that I could fix it, but I didn't really make any mistakes, so that was nice.
Is there a limit to the amount of bytes that you can write, or is it you can basically write as many as you want?
It,
'Cause I
things
don't know
get a
how
little
much.
bit things get a little bit harder if you want to write more than 256 bytes in a row, because you need to like basically you need to put the processor into 16-bit mode, and
Mm-hmm.
it just makes things a little bit more complicated. But it's it wasn't like too big of a difference between those. And of course, just like writing more bytes takes longer
Yeah.
and is more error prone.
uh, Pika Boy asked, does the SNES 9X have a limit on the amount of buttons that are recognized at the same time? I think that's why I can't get zero exit. So I don't know if you know
Uh,
the answer to that, but
I don't. It's probably not. SNES 9X doesn't have a limit, but your keyboard physically might. If you're using your keyboard, some keyboards don't allow you to press like certain combinations of buttons at the same time. I don't know if SNES 9X has an input display. If you can get that to work, then you can like verify that you can press the buttons you need to press.
mm-hmm.
But if not, I recommend BizHawk. I think it's like it runs a little bit slower, or like if kind of requires a more powerful PC, but it's like a much like better overall. And there is definitely an input display on BizHawk, which is yeah, just another emulator.
Somebody asked, how was the item swap first discovered?
The item swap has a long history that was before my time in Super Mario World.
Mm-hmm.
It was like a slow incremental set of discoveries. Um, and I don't know a lot of the specifics. I know that Nathan Isboard was one of the people involved, and I don't remember maybe Bahamut. But yeah, it was like somebody noticed that like if you took a hit while sticking out Yoshi's tongue, that he would stick out his tongue a second time, and then somebody like figured out that you could like get a weird null sprite in Yoshi's mouth this way, and then somebody else figured out that you could do an item swap, like a full item swap, and get like a different sprite than the one that Yoshi was tonguing into Yoshi's mouth. But I'm not sure how it all really went down.
It sounds like it was.
It's just like a history of a lot of glitches throughout a lot of games is like a very incremental history. Like somebody figures out this one thing, and then years later somebody figures out something else and realizes you can put the two together and do something else, and that's what happened with item swap.
Yeah, it sounds like someone accidentally did something, posted it on a forum somewhere, and someone's like, "Oh, that's cool," tried it out, figured out something else, and then it just kind of like that.
Yeah.
Somebody asked, have you been involved in any of the arbitrary code execution discoveries in the Zelda community of recent, such as Majora's Mask?
No, the only game I've worked on arbitrary code execution stuff for is Super Mario World. In fact, that's, I guess, the only game I've done any like any real tech discovery for. Yeah. Other than, I guess, Minecraft maybe, but not for speedruns.
I have a question. So in games like Super Mario Bros. 3, you can do a credit swap, but how come in earlier games such as like SMB1 or SMB2, SMB2J, why can't you do a credit swap? Is there like a limit or something that prevents you from doing it? Or
there's nothing inherent about the games. There might even exist credit swaps in those games. The limiting factor for a credit swap is basically like, is there a glitch that will crash the game? And A, like in the first place, and then B, like, can you manipulate things so that glitch doesn't crash the game and instead runs arbitrary code? And the more complicated the code is, the more likely there is to be a bug like that does like allow you to run arbitrary code. And so for Super Mario Brothers, for instance, like the game is just not that complicated. It's not doing a lot of things that like would cause a crash. Whereas Super Mario Brothers 3 has a little bit more going on, and Super Mario World, certainly, like Yoshi is extremely buggy. There's a list of 100 glitches that you can do with Yoshi. And Yoshi's Island is similar. Like, it's a very complicated game. There's a lot of code, a lot of things that can go wrong and be buggy. So I would just say the more complicated the game, the more likely it is for something to exist. But on the other end, like, if the game is too complicated, it could be hard to actually get the crash to do what you want it to do, to manipulate things in such a way. And that's why it's harder to find, it can be harder to find arbitrary code execution glitches on newer games, because often what's going on under the hood in memory is like totally chaotic. It's like constantly memory being allocated and deallocated, and it's hard to actually control what specifically happens when the game crashes and make it run your code. We've seen some stuff for N64 recently, and that's taken a lot of research, and they actually had to figure out how memory was being allocated and deallocated. Whereas in an older game like Super Mario World, memory isn't allocated or deallocated. There's like fixed tables that are always the same size, and so everything is always in the same place. It makes it a lot easier.
And I know, I don't know if this is true, but I think in games like Super Mario Odyssey, for example, which are on the Switch, if the game crashes, it doesn't really crash the console, it just crashes the game. So I don't know if that manipulate that to like
there's also kind of
credits, but
there's kind of inherent protections in more modern computer architecture that helps prevent arbitrary code execution glitches in the first place.
So I think that's gonna be it. If anyone has any last minute questions, you can definitely still ask them. But
all right, we covered a lot.
Be it. Yeah. So thank you again for being on the podcast.
Thanks for having me.
And I will see everybody later. Bye.